Hey everybody, how's it going? As usual, let me know if my sound is weird. Alright, so we are on episode 6 of building a game from scratch for fun and learning. So we do have source code for this. This is available on GitHub, and that includes the art assets. Those are all made through Inkscape, but they're saved in SVG format, so I think you can import them into Illustrator. So every piece of this game is freely available. You can just take it, have it, use the code in your own projects. Just kind of do whatever you want. So last time we spent some time working on the player animation and gave it some leg movements, and we also added this kind of spin move attack so that we could clear out these flowers. So now when we run around, we got this thing going on, which is pretty majestic. And then if I click anywhere, then that does this kind of charge attack. So we also added some camera shake to that as well. And so without sound effects or much of anything else, this move is still pretty mediocre. So we'll just have to kind of take it on faith that we'll just evolve this over time into something a little bit better. So I think this time around I've got some questions about resolution management and how you would manage people having different aspect ratios and different resolution on their devices. Things like cooldown on this charge attack, as well as maybe a charge up. So instead of just click and instantly charge, you would like click and hold or something like that. And maybe even adding a hotkey to it so that we could kind of make this guy into a League of Legends style champion where you've got maybe like 3 different buttons you can hit to do some different moves and stuff. So there's a lot of options that we have on what we can do. I think probably the first thing to tackle would be the resolution management, because we kind of hit that point in this game where we might want to hand it off to somebody so they can just poke around in it, and we want to make sure that it works well and looks good on their device. So let's do that. Okay, so we're just gonna make a script, and this could actually be a convenient script because managing resolution is something that you're gonna need to do in every game, and our convenience scripts are the ones where we're okay with just kind of like recycling them and they're not game specific. So I'm gonna put this might need its own thing. We'll make a new folder for now. Resolution set, and then so that's the name of our script, and then in our initializer object, in the create event, we are going to last thing, initialize the resolution before we go to the main menu. Okay, so I see a lot of early music's a bit loud. Let me turn that down. How's that? All right, so I see a lot of early developers using room sizes and also stretching the view when it comes to managing different like aspect ratios and stuff. That just inherently leads to a really bizarre kind of outcome where things are now like weirdly long or weirdly tall and they don't quite fit, and it just doesn't look good. And you would never see that in a professional game. So the question when it comes to a 2D game is how do you manage the resolution? Because you don't have a camera like you do in a 3D game where you can just like have more pixels rendered in the camera. And so the resolution comes down to, let me pop up an Inkscape so we can kind of take a look at what this means. Okay, so the way I like to think about resolution in 2D is through the concept of safe zones. So I'm going to actually make this thing the right size so you can kind of see. All right, so this is a 1920 by 1080 area. Put a 1 pixel black line on there instead of 20. Okay. So the way we think about safe zones is there's going to be like a chunk of the screen that we want to always see, no matter what. So let's say we've got some, UI elements up here, and we've got like some other stuff down here, blah blah blah. Maybe we got like a action bar down here. So this is kind of like what our UI looks like, and maybe our characters, in the middle somewhere. So one option would be to just kind of change the size of the viewport as we change devices. But let's say somebody's on an iPhone X, which is like a much wider aspect ratio. So you'd end up with something like this, which we did used to do this with our games. So it was a really bad idea. So you end up with something like this where now all of a sudden you see a lot less. Because an iPhone X is a lot longer, right? So if you scrunch the top down to make it fit, then now all of a sudden your screen gets super crowded. So the way we always think about these safe zones is we always keep this space visible, and then we just add stuff. So if somebody's on an iPhone X, which has a resolution that's going to look, something more like this, then we just add to the viewport on the sides, and then these UI elements would go further away. So you'd actually end up seeing more on these different aspect ratios. And on something like an iPad, which is tall, then you end up with something like this, and then we would move the UI elements like that. So you see how what you see in the middle is always there, and you never lose anything outside of the baseline. So that's kind of the approach that we're going to take, and we're not going to stretch anything. We're just going to add to the screen in either direction. So let's close that, and so we're going to have our minimum width be 1920. We're going to make this an HD. Now, I may need to look up some references on this because this is something that Hey, Dr. Voxel, good morning. Yeah, so resolution management is something that once you've solved it, you kind of never have to worry about it again. So I wrote this script once, like 6 years ago, and then I haven't looked at it since. So, first we need to figure out what's the size of the current aspect ratio that we're in. So, we're going to say display gate width. We'll say current width height is... So this is where you would see something like the 16:9, which is our original aspect ratio. So base width height is going to be our original mid. Min width, resolution, mid height. Which 16:9 actually comes out to, I think, like a 1.77 repeating or something like that. Hey, Bertiti, welcome to the stream. We're just working on dynamic aspect ratios. All right, so we know the current width, or the current aspect ratio of the display, and we know what our baseline is. So all we're going to do is, if we think back on our Inkscape model here, we're going to say if the device is taller than our normal one, then we keep the width and we just add that extra height. If our device is wider, then we keep the height at the min, and then we add the width. We just kind of, so we need to check. So first we say if current width height is greater than base width height, So that means, in other words, the device is long. So we need to expand the width of the view. So we're going to store this resolution width variables and resolution height. Start with our min. And then we'll update those if we have to based on the aspect ratio. So if our screen is long, then we're going to go ahead and say resolution width is going to be resolution height or min height. I think I want to say divided by, no, times. Hey, the rumpus. How did the big level head update go? Smooth as butter. It was kind of nerve-wracking because it was a lot of web tech, which is kind of hard to test because everybody's got different sets of data and you never know who's got legacy data from 10 years ago, you know, and all that stuff. So here we say the device is tall, like an iPad. So we need to expand the height of the view. So in this case, we would say the height of the resolution is the width divided by the aspect ratio. I think. So you notice in both these cases, so let's do this else here just to be safe. So here we're saying like if it's too long, then we only change the width but keep the height. If it's too tall, we only change the height and keep the width. And if they're equal, then we just don't change anything. So now that we have that, we want to take a look at, let's see, I've got my little reference over here. All right, so we're gonna iterate over all of the rooms. And the question is, how do we do that? Because right now we only have 3 rooms. I'm just gonna, rooms actually just have ID numbers that just start with 0. So you can just do this. I'll use R's for a little more clarity. Room, get camera. So if the room already has a camera, then we're going to destroy it. Then we're going to make a new camera. Equals, let's see, camera, create view. Okay, so then we give it the variables, which is like the position in the room, and then the width and the height of the camera, or the view. So this is where we're going to say resolution width, resolution height. The camera angle is going to be, yeah, so the rest of these variables are optional, so we're just going to not worry about this. I already used Unity. Yes, I used Unity for about 8 months when working in another studio. Unity is a fantastic tool. Game Maker is just kind of where I've put most of my time, and I've also come to prefer it for 2D development. Okay, so we've got, let's see, room, set viewport. Vend is the index of the view. So rooms have 8 views available, which is how you can do things like split screen and stuff like that. So we're just operating with view 0 for now. But you could, if you wanted to, iterate over all of these, like everywhere that we have these zeros, or these zeros, and replace them. Just for safety, I'll do this so that it's more obvious. Visible, true. Export, resolution width. Oh, sorry, export is 0. That's position. So, with GameMaker Studio 2, Yo-Yo Games changed all the camera functions, and as I understand, like, they're a lot more flexible, but the implementation and the language used to talk about the cameras now is very confusing. So I've actually in most cases like once I figured out what it was doing, then I would just abstract it into a script that I could understand and then make my own functions to make it do what I wanted to do. Okay, so we have room set, viewport, and I think, let's see, I think we also need to set the camera. View index. Ah, there we go. Okay. And then we need to view. I think this might do it. Yeah, let's give that a try. Oh yeah, there's one last thing too. Display set GUI size. And that's going to be that stuff as well. Alright, so if all goes according to plan, this won't crash, and it will look exactly as it did before. Okay, so I think we're... Potentially this is fine. So we're going to do some experiments here. So for starters, we want to say display, oops, set, let's see, we want to set the window size. It's just window. Yeah. Window set size. So there's a couple of edge cases that we have to think about here. Okay. So let's just test something here. Let's just change our min and our max. So we could cut this in half. Let's see, 960 by 540. So this should technically give us a tiny game. Right? So this is... Can't really... So you notice how it basically just kind of chopped the edges of the window down. And if we wanted to go bigger, we could also do so I want to show you some examples of how this can go wrong, and then we can fix those. So here we're going to say, yeah, now we're just going to go width and height of the whole display, and that's just what we're going to use. Okay, so now we have this window that can be dragged around, and it kind of goes, because of the bar at the top, it's actually incorrectly sized, because now we can't see the bottom of it, and then there's the taskbar down here. So this is not great, right? Can see a lot more, which is pretty cool. Okay, so where would you add in a universal multiplier? Room last. Yes, we'll use that. I want to say less than equal to. What do you mean by a universal multiplier, Shamus? While you formulate a response, I will keep going. Okay, so there's a couple things that can go wrong here. Oh yeah, let's also just double check. So what I like to do for testing is actually create some alternative aspect ratios that we can use for testing. So say like iPhone X. So dynamic is the aspect ratio that I would use by default, which is one where it just changes based on the size of the screen and the user doesn't have to do anything. iPad 2 and we'll say ultra wide or something. So scale everything by 2, for example. All assets are 64 by 64, but everything is drawn at 128 by 128. Oh yeah, so for that you would just change the viewport. So down here, so here we have camera create view. So this is, you know, the width and the size of the view, which is all fine. And then in here we have room set viewport. So I could change like resolution width, cut that in half. And I would also potentially, if this is not a full screen application, I would cut the window size down. So let me actually turn this into a variable instead of a magic number. So the viewport is just the size that we render the space in. So see how now we can see the same amount of stuff? It's just small, right? So this is the same exact volume of things that we're able to see as we could before. And so that all comes down to the viewport. So we could do a full screen. So I'll cut out this window set size. So let's see what happens with the viewport in here. Notice how I set the viewport size, but nothing changed. I can still see the same amount of stuff. That's because the viewport is sort of like only relevant really if we're dealing with full screen. So yeah, like I said, there's a lot of like weird layers in here. So let's see. So we could try full screen. Actually, I don't know if viewport is even much of a thing anymore. Room set viewport. What if I just comment that out? That too. Okay, so now we're in full screen. Oh yeah, there's no exit button. You know, I'm gonna put that on my list. Escape to exit. That's one of those, I can't believe I missed that. That's one of those things that you'll see, especially in like jam games and stuff, is you open up the game and then the only way to close the game is to go into your taskbar and force quit. It's one of those quality of life things that doesn't seem to matter that much while you're developing, but it's very annoying to deal with as a player. Okay. So we have the viewport here. See, I'm kind of wondering, does this viewport thing even matter? Or is that just old stuff? Yeah, I'm just gonna cut that out. Okay, so we have this ability to adjust our view, which is nice. And we can also test how it would look in different aspect ratios. So let's put together a little test script here, or a test section. So our dynamic aspect ratio, we're not going to worry about. iPhone X, we're going to use, I think it's like 2.15. iPad is 4:3, which is this. And then ultra wide, we'll just do like 3 or something. Okay. So then we have a resolution width, and our default information up here. I'll initialize these up top. Okay, so we have our current width and height, and now I'm going to create a test variable. So we can force the aspect ratio to be different things, and we can see how it ends up looking. So this is an important step because we want to make sure that even though it might look good on our machine, you know, somebody else might have a weirdly tall device or a 5x1 monitor or some crazy thing. So we did end up getting a thumbs down on, but from someone on Crashlands because they kept trying to run the game across 5 monitors simultaneously, and we didn't handle that case very well. So, yeah, these things happen. All right, so case aspect. I should just say if aspect ratio test is not dynamic, then we will force the width and height to be test. Okay. So what this means is I should be able to swap this out and say, let's just real quick. Yeah, I'm sure 3 of the monitors were 90 degrees, 1 was 45 degrees. Okay, so I've shrunk this down just so that we can actually see the different sizes, because if we start to expand it triple wide and stuff, then we're going to lose track of it. So this is our baseline aspect ratio, and this is calculated from the monitor that we're running the game on. So let's try ultra wide. Maybe we do need the viewport? I think we do. This is why we test. Let's see. Viz true. This isn't doing what we need. I think we are backwards. Let's try some other aspect ratios and see what happens. All right, what's going on here? Let's debug this thing. Okay. So we have our minimum width. We have our base. Okay. So we're taking the aspect ratio, and then we are overriding it if we are not in dynamic mode. So if the current aspect ratio is greater than the base, ooh. Let's see, surface. I might need to update the application surface. There it is. Okay. So there's a lot that goes into this. So this is how the game would look on an iPad. All right, so what happened there was there's a surface, which you can kind of think about like a canvas that Game Maker paints to every frame, and then every frame it will wipe it and then put all the sprites back on top of it. So the application surface is just the like final rendering space for the game. So if we change the size of everything, but we don't also resize the application surface, then none of that really matters. So this is looking correct in the sense that we can see the same amount of stuff side to side, we just get more stuff vertically. And actually, let me, just to kind of show this a little better. I'm going to draw a big rectangle. Minus, let's see, 60. So I'm going to draw a rectangle that shows the safe space that we talked about. We're going to make it lime. I hope the depth of this is fine. We'll see. Okay. So this should kind of help to demonstrate. Alright, so this green area was our original 16:9 aspect ratio. So if somebody's playing on an iPad, they get to see that extra little amount on the top and the bottom. And if we switch the aspect ratio again, so we can try, let's look at an iPhone X. These can just be vars. We don't really need a macro for that. Unless we need to use them somewhere else or whatever, but it could also be an enum. Let's use an enum. Nah, who cares? All right. So we're going to test. All right, so if somebody's playing on an iPhone X, you notice that now it's pretty long, and they get this extra bit of space on the sides. When it comes to game dev concepts, what was the hardest one to conceptualize and implement? Probably Perlin noise. Because everywhere you go, people have these unusual opinions about how it has to be done. And they're usually hardcore math nerds. And the fact is, like, it's a fairly straightforward concept. But people will get you tangled up in the weeds of all the different details that they think are important. So I read tutorials for a week trying to learn Perlin noise. Couldn't figure it out. Ended up just, instead of reading tutorials on how to do it, I ended up just reading about Perlin noise, like what the concept is. And once I kind of figured that out, then I just made my own implementation of it. All right, so let's test out this ultra wide and make sure that everything is square, well, rectangular. All right, so if somebody's playing on some kind of bizarre long phone or something, then they get this. Notice how in all cases we are in totally good shape. So we're going to switch back to the dynamic aspect ratio. But at any time, you can add more aspect ratios to test your different interfaces and stuff. Oh yeah, pathfinding, A-star pathfinding was also very hard for me to figure out. Because again, people have very specific opinions about how to do it. I think it's also the case that a lot of times in tutorials, programmers use unusually convoluted variable names. that are like super abbreviated and don't make a lot of sense. My biggest pet peeve is in programming books when they always use foo and bar to represent variable names. Like, what is that? Just use actual human words and make a program that talks about some concept that people understand. Let's say foo equals 6 and bar equals 9. Foo plus bar, blah, blah, what? Come on. All right. So we've got our aspect ratios. We've got our resolution stuff. I'm going to go into my controller. I'm going to delete this big old rectangle. Actually, I'll leave this in. And if anybody wants to play around with that. Resolution safe zone visual demonstration. Okay, so there's one last piece of this. There's one last piece of this resolution puzzle, which is that problem that we saw before. Let's say that I decided my resolution minimum width. Let's say I'm saying, you know what, this is gonna be a frickin' 2196, whatever. You know, I got this big old game, and this is my minimum. Okay, what happens if somebody plays this on a device that just doesn't have that many pixels on it? So let's boot it up and find out. Okay. Oh yeah, I cut the whole thing in half, so that obviously would counteract my point here. So okay, so you see what's going on here. I set the size of this thing, and it's huge. Also, we got these black bars on the side, which we would have to figure that out. But what's going on with this? It's probably the case. I don't know, you guys can't see, but like this is going across both my monitors. So how do we solve for that? Well, it comes back to this view size multiplier. So we just need to kind of crunch the window down a little bit so that it fits inside the view. So we would just say want to be a minimum of, sorry, what am I thinking here? We need to get the display size. I'm going to get the resolution and width. Okay. So we want to say this will constrain it so that the width gets locked into, or so that the window gets locked into being 90% of the screen size. So because of that extra bar and stuff like that at the top, we just want to give ourselves a little bit of cushion. So I think this will do it, right? So just for safety, we can talk through the math. So if our display is, let's just make some easy numbers. If our display is 2000 and our resolution is 3000 wide, then 2000 divided by 3000, so we would cut it down by 2/3, and then we'd take about 90% of that to kind of pull it in a little bit more. So I think that is right. Good morning, Zivix. Okay, so this is what it would look like if I told the game, hey, my resolution is 4000 by 2196. My monitor isn't big enough for that. So notice how the window now gets nicely automatically shrunk down to fit my view. Okay, so now I've got this 4K game. So we get a lot of questions in Levelhead about people with like a 4K monitor or something like that wanting to have higher resolution. And this is kind of an interesting problem with 2D games because 2D games are only they're made of static images. So you think about how when you play a 3D game, there's always separate settings for texture resolution versus various rendering settings like anti-aliasing and stuff. So you notice in a 3D game, if you increase your resolution in the game, the textures on the models don't get any sharper. That's because the textures just have as many pixels as they have, right? So the same thing goes with a 2D game where everything you see is just made out of the pixels that it has, and we can't like make the game more crisp by giving you a higher aspect ratio. We can show you more stuff, which is what we have here. We just expand the view so now you can see more things. But in some cases, that would end up breaking the game. So if you think about it in a game like Levelhead, where now all of a sudden, at certain aspect ratios or certain sizes, you would end up just seeing the entire level, which means now you can't have secrets or some camera functions would break. So there's a lot of considerations that go into how to handle different resolutions. And in Crashlands, we actually do this. We actually allow you to just increase the resolution, and it'll just scale everything up, and now you just see more stuff. But it also makes it feel like you're moving more slowly across the screen. So there's a lot of things to think about, but baseline, I'm going to keep this resolution set script in the project. So anybody watching this stream, making a Game Maker game, you now have no reason why you would ever make a game, even a jam game, that doesn't properly fit someone's device. Because you got this now. Okay, let's get out of here. Gonna push that. Game now has a dynamic aspect ratio. What size PNGs do things typically get exported at? Seems like they need to be pretty huge to scale well. Yeah, it really depends on the thing. In the case of, say, like the Levelhead avatars, we actually have 3 different versions of the avatars. We have all of the avatars at essentially, you think about it as like 300, 130. Which does blow up the file size, but actually what we found is that audio files have a bigger tendency to skyrocket the file size. PNGs are pretty well compressed, so it's not as big of a concern. Okay, so we have our aspect ratio. That's done. Now we need to get this escape to exit, because I don't want to have to keep force closing the game every time. So let's do this. Let's make an interface folder. All right. And what you would normally see is maybe in the gameplay controller or something, somebody might be like, oh, let's see, escape. And that's going to the main menu, and then in the main menu, we're going to also put an escape event. I'm showing you kind of like the most obvious way to do this, and then I'll explain why that's going to cause some problems down the road. All right, so this would work, right? Gameplay controller, I press escape, go to main menu. Main menu, press escape, game ends. Let's test it. Space, okay, escape, and we're back, and escape, and the game is over. So that's all well and good, except if there's one thing I've learned about back buttons over the course of my game dev time, it's that every single thing in your game is going to have a 300, 100, that's pixels in size. So 300 by 300 pixels, 100 by 100 pixels, and 30 by 30. But depending on where in the interface those avatars get shown, that's yeah, we don't really worry about PPI or DPI because that's more of a printing thing. It's just how many pixels it is. Okay, so here we are. All right, so back to the back button stuff. So you notice how I have two separate events here, pressing escape. And these are never going to clash with each other, but what if we have a pause menu? Like you hit escape, opens up a pause menu, hit escape again, it closes the pause menu. Hit escape again, it reopens the pause menu. What if we have like a crafting window? You open up crafting, hit escape. You want that to close the crafting window and not also open the pause menu, right? Like there's a whole bunch of functions that are all tied to the escape button. And you only ever want one of them to happen at a time. So we're going to make sure that that happens by making a function called trigger back action. Okay, so we're going to make a cascading decision tree in the script where it's just going to keep asking like what's happening now, and if we hit something that we need to get out of, then it'll take us out of that thing and stop, and it won't take us down any farther than that. So first we're going to check what room we're in. Okay, so this is all that it is for now. Later on when we add pause functions and stuff like that, we can add those into this script and make sure that we don't have to worry about that. Gameplay controller. So now instead of pressing escape, we're just going to delete that. Delete both of these, and the step event for these under gameplay, that's where we can do this. And you also notice right now I have these things are hard coded, right? So the escape key and R key and stuff like that. Later on, we can make a universal input controller that will be able to listen to all kinds of different inputs, like a B button on a controller, or a start button on a controller, escape button, mouse clicks. We could even make virtual controls on the screen and then trigger inputs through that. So, but we just need something to work. So that's what we're doing. Okay, and then in the main menu, we'll do the same thing. And so the reason that I put these in step events is so that they can be rebound, and also so that I can search for them. So if I ever did a search, for VK escape, now I can find it. If it was inside of an event, I can't find it. Will we be adding mind controls? Yeah, there'll be some mind controls. That's one of the inputs. All right, so we have trigger back action. Let's load that up. Press space. Perfect. Push that out. Okay. Resolution management done. Back action done. All right. So we talked about then cooldown on the charge attack, charge up on the charge attack, and a hotkey. Probably once we have those, then we can look at maybe adding some enemies and potentially more abilities. So we'll just kind of go as far as we can today during the 2 hours and just see where we land. Okay, so we can just do this. We don't need to worry about developing an entire cooldown management system just yet. Instead, we can just code this up uniquely, and then we can refactor later if we have to. So we're going to say region abilities. So we'll say charge attack, cooldown. We're going to call this a dash, because if we want to use the word charge to describe charging something up, then that's going to get confusing. Dash attack cooldown and max cool. So we'll give it a half a second. No, we'll figure that out later. Okay, and that's literally all we need for that. And then up here at the top, in the player's step event, we can decrease cooldowns. So we just say dash attack cooldown is max 0. And technically, we don't even need to do the max. We could just subtract slow-mo seconds every time. That's also fine. All this means is we're just going to constantly be decreasing this cooldown. And whenever we attempt to charge, so here's our charge attack input, which is, clicking the mouse button, right? Next we're going to say if dash attack cooldown is less than or equal to 0. And then when we start charging, we set the cooldown to the max. And then, so I'll do this, and then we can also throw a little debug in there so we can see it working. So now I'm spam clicking, and now there's a half-second cooldown between each of these. So cooldowns are pretty easy to work with, and the reason that I'm not using the alarm system in GameMaker is because notice that this one allows me to use my slow-mo seconds. So if I, for example, in the, let's see, gameplay controller, if I just set speed, if I set the game to half speed, then now the cooldown is twice as long, right? So now everything's going to respond to our bullet time in a very flexible way. And also, when we pause the game, because of that speed function that we made, pausing the game is literally just this. Like if you just set speed to 0, the game is paused now. So, good. All right. So we have our cooldown. So I'll just push that. That was pretty simple. Origin. That's between Bitbucket and GitHub here. Okay. Got our cooldown. Now I think what I'd like to do is, before we add any kind of a charge up, I'd like to add a hotkey to it. And then probably even get some, now that we have a cooldown, we probably want to have some kind of a display on the screen for what this is. So let's go into our Inkscape file here. I'm going to grab my 1920 by 1080 image, and I can use this as kind of like a basis for planning interface elements. So here's how much space I have to work with. And I want to put something maybe just like in the corner, like a circular icon that I can then attach a hotkey to or something like that. and we would use this to display the cooldown. So this is 109, 109. Let's go 100 by 100 just because as a human I want numbers to be certain things, even though it's arbitrary. Okay, so here's our 100 by 100 circle, and we want some kind of do a circular timing bar so the circle fills up slowly. Yeah, that's definitely weirdly involved. So probably what I'm going to do instead is I'm going to fade it and then have a circle emanate from the center. Because if you want like a line to fill the circle up like that vertically, then you essentially need to like render a rectangle across it and sort of cut out the circle in the middle, which is a lot more complicated than you would think. Computers love rectangles, but circles, not so much. In that case, though, we could just do a rectangle. That's also an option. Okay, so we need to come up with some kind of an icon to represent this ability. I think first we want some kind of a cool looking interface element. So I could like do this and gonna align these and chop that out. Now we've got like a button border kind of a thing. Pull this in. And I'll make this backdrop fairly opaque. That. Okay, so there's our button thing. And we want to somehow convey this dash attack, but because this image is so hideous, I think we probably just want some kind of like an icon or something to convey what's going on. So let's see if we can come up with something. But basically it's like we want like an arrow kind of a thing with like a spinny vibe to it. I'm not totally sure how to execute this, so. I'll just kind of keep wiggling lines around till we get there. What's this? Is this what we need? Can we just do this? Kind of like an aqua blue. This might work. Uh-huh. Maybe? Figure out how to mount this arrow onto this thing. We really just need to convey, you know, the idea here of what's going on. Thinking I could maybe like add a little bit of shading to this arrow. Maybe that would kind of do it. We don't need to go too fancy here. Just enough to be like, look, it's a spin move. Okay, so we have that, I guess. Not my finest moment. I think we're getting there. Okay, that's gonna be good enough. That's our spin move icon. Okay, and then we're gonna give ourselves a bounding box for this button. Make it even on all sides. And then we'll get that exported. Later on, we can update these icons and we can reuse the button backdrop for other buttons. And another good kind of rule of thumb is your bounding boxes for your sprites should only really be as big as they have to be to contain the sprite. So that way you can use functions like sprite get width and stuff like that, which will help you to use code to manipulate images. So it should be pretty accurate. When it comes to characters, it's tougher because they need to move around a lot and change shape. But UI elements, you can be pretty tight with the bounding boxes. Okay, we're gonna export that. Export as, this is, ooh, actually, you know what we're gonna do? Take it back. We're gonna have a separate button sprite. So we can reuse that every time we want, and if we want to change our button appearance, we can just do that. Ability button. SP icon spin attack. Hello, Kenny. Welcome to the stream. Yeah, apparently the last stream got messed up its audio when I clipped it on YouTube, so I'll have to re-upload that. All right, I'm gonna clean this up a little bit here. Got too many things happening. Also, this berry spread. So these are all old. SP player and SP berry. So I'm just going to delete those. And now we need an interface folder. Okay. And we should be able to grab our button. So I did mess this up though, because this is a 104 by 104, which means it has no middle pixel. So I'm gonna re-export that. So for a lot of things, that lack of a middle pixel doesn't really matter. For interface elements, it can get really annoying to have things always be slightly off in one direction or another. Spin attack. Let's see if that does it. $105. Okay. Now we have a middle pixel. Button ability. Backdrop. These could end up becoming buttons on mobile or whatever. Okay, so we've got our button and our spin attack icon. Let's get these put onto the interface, which we don't even have. So let's make an interface. All right, first, interface. We'll say, gameplay interface. There's gonna be a lot of interfaces. So let's, keep it under control. All right, gameplay interface. So we could spawn a separate object for this spin attack thing. Yes, let's do that. This is gonna take some refactors a little bit later, but. Zacy subscribed with Twitch Prime. Thanks. I think that's good. I'm new to this whole Twitchy thing. So let's see. Ability icon. All right. So essentially where I'm at here is I want to just convey on the screen that this ability is on cooldown. And we can also use this to convey that it's charging up. My language for talking about how this works is going to be kind of loose for a while because I don't quite know whether or not these are going to be buttons or whether they're going to be just visual elements or what. And also the way I'm going to set these up is going to be a little bit haphazard, and then we can refactor them later as we expand and give player more abilities. So let's see. So ability icon. So this thing is always going. So we're gonna use draw GUI for this. And the draw event. This is an interface element, so it's just not gonna do anything. And for those who don't know about the GUI layer in GameMaker, it's a totally separate layer that lives apart from the normal game world. It doesn't move with the camera, and so as you zoom in and out, then things just kind of stay the same size. So I always put any buttons and interface elements always on the GUI layer. Okay, so ability icon. This thing's gonna have a width of and actually let's make a parent interface object. Interface element. So we want all of our interface elements to have a certain set of variables that we can access in order to more easily work with them. So we're gonna always give them a width and a height, and we'll worry about the rest later. Parent of the ability icon is gonna be interface element. So the reason we do this is so that, for example, we could deactivate all the interface elements when we pause and then reactivate the interface elements. So that might be buttons, could be things like this icon or like a clock or whatever. Okay, and so we're also going to inherit this event. The ability icon, we're going to draw it down here. Scale. Okay, So we want to also update all of our interface elements to have a scale so that we can squish them and do stuff with them. Okay, so there's our ability icon, and for now this ability icon is just going to be hard-coded to be the spin attack, and then we'll update it later. Don't be afraid to just make a specific implementation of something. Once you do something a couple times in different ways, you'll see the patterns, and that's when you go back and refactor and clean it up. Talk gibberish. Welcome. Okay, so we have our backdrop, spin attack, and now our gameplay interface is just gonna spawn this thing. So the question is, where do we put it? Let's see, GUI. Okay, so when we create the ability icon, we can put it wherever we want. I'm going to put it half width from the left with a 5-pixel margin and half height from the bottom, also with a 5-pixel margin. And in our gameplay controller, we can create our interface. Okay, so this should spawn, so just a quick recap, gameplay controller is going to spawn the interface, interface is going to spawn our ability icon object, and all that that's going to do is just draw the thing to screen that we made in Inkscape. So it's not going to be responding to anything that we're doing just yet. Okay, so we see it down there. Nice. Just kind of doing its thing. Might be a little bit kind of too out of the way if we're going to be looking at it for cooldowns and stuff. So let's just put it in the center. Okay, so we have our move here. Okay, so let's say we want to attach the spin attack to Q, right? We got this. We're basically building League of Legends here, right? So I want to draw that on the ability icon. And again, this is all hard-coded. We will update this once we actually get an input system and more abilities in there. Hotkey display. So let's check out a regular font here. Yeah, this should probably be fine. So I'm going to right justify and bottom justify, and then I'm just going to draw the hotkey sort of in the bottom right corner. Draw text, x plus width, 0.5 times scale. We're going to draw hotkey display. Scale like this, color, make it soft green. All right, so this is gonna look baddish. We gotta make that not be the case. So an easy way to do that is through making shadow text, which is pretty easy to do. We're gonna make a script called shadow text. To make a drop shadow underneath text, you just draw the same text twice, but darker. So we're going to draw text. Thanks for the sub. Let's see. So text, XY text, scale, color. I'm just giving this the same arguments as before. Color, rotation, alpha. Twitch Prime. Yeah, thanks, Jamis. Alright, so we're going to just run draw text 2 times, and we should also say drop shadow pixels. We're going to use 2 pixels by default. Okay, so we're missing a script here as well. So we'll quickly fix that. So we're going to say the drop shadow color would be like half of the color values of the base color. So we need to make this script. But we can override that as well. Text, drawing. Let's do this. Oh, we have our color darken. That's what we need. Not change. We already did this. Oh, hey, Adam. Yeah, my mic is mounted kind of like floating up above the keyboard. So I think that probably helps. And the mic stand is actually mounted to a separate table right next to my desk. And it's kind of like swooping over. Scale. I see color. Okay, so that's our normal text. And then our background text. We're going to drop it down. We're going to change the color to drop shadow color. That should do it. We're going to just get these arguments laid out so we know which is which. And we can also make these optional. Yeah, I think it's important to have a loud keyboard. I think it makes it feel like you're really doing something. So I'm lining these up for a couple reasons. One is it makes it easier to see if I've accidentally missed a number, and it allows for vertical selection. Okay, so now rotation is optional, alpha is optional, drop shadow pixels, optional. Rotation is 0 by default, alpha is 1 by default. Keyboard that clicks or that clacks? I'm not really into the clicky keyboards. They feel like they have kind of a resistance. You know, when like you press down and then there's a moment before it clicks. I don't know. X, Y, text, scale, color, rotation. Okay, so this should allow us to make a drop shadow. So let's try that. Shadow text. Okay, so This is where we're drawing it. This is the text. This is the scale. Oh, I put color. Rotation, alpha. So by default, it's going to drop shadow 2 pixels and darken by half. We could just try the defaults and see if that's more readable. Oh yeah, if you're using a VoIP program, I've noticed that on Skype, if you start typing with a mechanical keyboard, then the microphone sort of just explodes and won't take your voice anymore. So, okay, so notice that Q is quite a bit more readable, but it's still kind of dumb. So, what do we want to do? We want to go drop shadow pixels. Let's go more pixels. And let's darken it quite a lot. Okay, that's a little bit better. We can also just move it down a little bit more. Just kind of get it out of the way. So bear in mind that, this isn't what we want our final interface to look like. This is just a functional stand-in. We want it to be the case that when we hand somebody the game, that they can just do stuff. So that's what should be obvious, that they should press Q to do something, and they should be able to at least kind of poke around and experiment and see what's happening with that. Okay, so we have our ability being drawn here, and we need to hook it to the letter Q. So let's go to the player, and instead of left mouse button being pressed, oops, keyboard check, pressed. Q, and then that's just going to do the same thing. So now I'm pressing Q, and now I am charge tacking. So presumably we want to reserve the mouse for something else, some kind of like generic interaction. Like maybe if I clicked on this flower, then I'd go and do, I don't know, harvest it or something. And then Q is just my dash attack to explode things or whatever. So let's get the visuals updated on this button at the bottom so that it shows some kind of a cooldown. Yeah, I'm currently moving with WASD. What I've found is that if you give somebody a PC game that only moves with the mouse, even though some of the most popular PC games control that way, if you make a 2D game that controls with the mouse, people will immediately call it a mobile game. So you always have to have WASD movement, even if it's worse. Just because. PC gamers, they got all those gadgets, gotta use them. Alright, so our ability icon, all we really need to do for now, probably, is just darken the spin attack. So, spin attack alpha equals 1. And now we can use our width function to reach into the player object. And we can say if cooldown, what was it called? Dash attack cooldown is greater than 0. Spin attack alpha is 0.5. Let's just do this to the whole thing and see how that looks. That's true. Diablo is a mobile game. That is happening. Oh, right. A pin attack. There we go. Okay, so now you can see that this thing dims when I move, which is nice. It kind of gives a sense that, hey, you can't do this. It does not, however, give a coherent sense of when I would be able to use it. So what do we want to do about that? Let's get the percentage of the dash attack and then have like a circle in the background of the icon that kind of like or something. I don't know, I'm just making stuff up. Okay, cooldown percentage. That's going to be dash attack cooldown divided by dash attack max cool. But since it's backwards, then it's going to be like 1 minus that. Spin attack alpha is less than 1. Draw circle color. I'm going to draw this behind the button. X, Y. Circle radius, width front to scale. Circle radius, we will make that, I'm just going to make it super red just so we can see if we can even see this. Hey, my sound effect worked. I like that. That's cool. Global cooldown mechanic. Oh god. People love global cooldowns. Okay, so now you can see back here I've got this sort of like growing thing. So let's think through this. What do we really want? So we have all of the math going on to convey what's happening. The question is, visually, what would make the most sense? I think actually knocking the alpha down is not what we want. So let's... color modifier. Let's try this. What if we just darken it? Darken the spin attack. There we go. That's kind of interesting. Depending on the icon, this might not work because you wouldn't be able to necessarily see through there. We could do... See, white isn't really good. Alright, we should probably also... green. So if dash is happening, we can gray that out. We could even, I guess, hide the hotkey when it's... It's fine. Yeah, and then just to see, what if we applied the same text color treatment to the border? We can go black. Spin attack. So color mod, this is actually the icon color, so. And let's also use consistent underscores here. All right. So let's take a look at this and see. Keeping the circle behind the icon when it's able to be used. Ooh, actually, now that this is black, maybe. The circle would be white. It'd be like it's filling it up. Huh? Yeah? That's a little hard to see. I think that'll do for now. So on the player, so we can try just seeing like, all right, what happens if this is like a 3-second cooldown? Do we get a good sense of what's happening? I also notice how it goes a little bit too far. Kind of goes. Yeah. Okay, so we have an ability with a cooldown, so that's cool. Cooldown feels a bit long. I'll put it at 1 second. We can keep tweaking that interface as we get more abilities in there. All right, so now we say we can press Q to dash instead of clicking, and we display the cooldown for the ability on the interface. Okay, so charge attack now has a hotkey, and we actually tell the player what that hotkey is. There's something else that's kind of bothering me, which is the cursor. Like, it's just the default Windows cursor. So maybe we should not do that. I think ideally we have some kind of a thing where, like, when you're mousing over valid terrain, then the cursor shows one thing, and when you're not, then it's something else. Let's do that. That's kind of a nice little polish point there. Let's see. What makes for a good cursor? This, then we're going to jam a node in there. I'll use his hand with a pointy finger. You're gonna make me draw hands? Ugh, that's the hardest thing to draw. Let's see. How do you draw a hand? We need, like, base of the hand. I guess that's the hand part. Hand, and then it's like there'll be a stubby finger coming off of it, and then like a knuckle like that. And then don't worry, it kind of looks like a middle finger right now, but we'll tighten that up. Go to deep focus mode to draw this hand properly. Okay, and then it's like that. So I guess you would see kind of like finger coming back like this. And then kind of like the thumb is tucked under or something. I've got a rambunctious dog. Woke up from her nap. Is this doing it? Is this doing hand stuff? Seems like maybe. And I think we need like shading there or something. I used to do a lot of art when I was a chid. I also made all of my own games for the first probably year and a half or two that I was learning how to do all this stuff. So I had to make my own art. Learned a few things. Hands always gave me trouble though, so I'm not quite sure how this one came together like this. Oh yeah, there's a guitar coming. Don't worry, people power fan. If you keep coming back week after week, at some point there's up to a 30% chance that there'll be guitar. What's going on with this? Why does it look like... Does this thing need fingernails? Is that a thing? How do you guys think, like, cave people trim their fingernails? Way back in the day. When all they had was, like, a rock. Do you think they just, like, sanded them down. Chew. Yes. All right, we got that. I mean, his hand is not very detailed, but what are you gonna do? It's perfect. Okay, so this is like our, hey, I'm gonna click on stuff hand. And then, unfortunately, this character does not have a middle finger. So, we can't switch it to that if you can't do something. Hey, Atlantic. Alright, so I need to figure out how to convey, like, hey, you can't do that thing. I don't know if I can, I don't know if my hand skills are that good, so let's start with this one, and then we'll try to do the next one. This is gonna be cursor hand. We might want to go a little bigger with that, huh? All right, so we need to make a cursor object. And this is going to be rendered on the GUI layer. Now we'll just draw the cursor and get some global variables in here. What am I making? That's a good question. I don't fully know myself. This is just a stream to show people how stuff is made in Game Maker and how games are programmed. And the game itself is kind of just whatever happens next. So far it seems to be some kind of top-down, fighty, perhaps gardening game. Okay, so at the end of our, or I guess, let's see, draw GUI begin equals, I think we can do this. And we also probably want to track where the cursor is in the world. So the reason I'm turning these into global variables is because there's a good chance that later we may need to convert these into arrays and track multiple cursors for multiple players. I'm going to draw GUI begin. For now, we can just take these values. So what you'll see is when we start using the controller, we'll actually take over these global variables. And when you push the joystick, then that's when we move these values around. So this is why instead of just baking in mouse X and mouse Y and all that stuff into the code everywhere, we're going to use these global variables, which we can then hijack and do stuff with later. Cursor hand, 0. So now we're going to draw this at cursor X. GUI. Now we have to actually render this thing. And let's go ahead and make the cursor object here. And the cursor object will be persistent. So when we change rooms, it does not go away. Do I mind you posting a 5-minute video in the chat? I do mind. Why would you do that? All right. So I've got my little cursor hand here. Oh yeah, no. But you notice that now the Windows cursor is now on top of my weird little hand. So I'm gonna turn that off. Go into the options here under the Windows settings. Why so strict? It just doesn't make sense to go into somebody's live stream and then pull people away from the stream to go watch a different video. Seems a bit rude, if you ask me. Which you did. So, now you know. Alright, so I think this hand is a little bit too small. So let's beef that up. I think I'm just going to blow the scale of this thing up. I'm just going to export this like this, and we'll just see how that looks in game. Then I can try my hand at making the hand closed. Well, People Power Fan, I do appreciate you asking. It's better than just popping in and dunking links. Okay, so we got a pretty good sized weirdo hand here. I think that'll do it. And I also want to add some responsiveness to this. So when I'm clicking on stuff, there's nothing happening. So I'd like to kind of make like a little ping. Which I think we have just enough time to do that. So this ping object, we want to be the same dimensions as the grid, so that it kind of feels like it's living in the world. One of the worst things you can have in your game is just a lack of feedback. And so 4x106. So even if the player tries to do something that they can't do, the game should somehow convey that that's what's happening. Did I make all those assets during the stream series? Yeah, these were all made on stream, and they're available in the source code files. So if you're interested in just breaking them apart and seeing what they have in them, or if you want to just use them for something, you can just go ahead and do that. Okay, so we're gonna make, I'm gonna set this aside just for safety. So we're gonna make a ping object. That's kind of like, just kind of like a little thing that when you click, it'll kind of spring out. How long will I keep streaming? I've been doing these streams for about 2 hours, so we're just about coming up on the end of this one. This is the 6th episode, so this is now sort of like into the 12th hour of working on this game. I think what I want to do here is kind of chop it. I want to make something kind of similar to what I did with that button. So I'm gonna do this. I'm gonna chop these out like that. And then kind of put a slightly transparent thing inside so that that also gets some color. Yeah, that should do it. Nice and easy. Ping. And then that's about 1 grid space right there. So could be fine. We'll stick with that for now and see how that goes. It's going to be called SP Ping. Hey, so Jim, thanks for watching the streams. It's always nice to hear when people find use out of this stuff. My approach with all this is just to think, when I first was starting making games, there were a lot of things that I just really wish that I had seen or known, and so I think it's important to try to put that stuff back out into the world, so that if somebody else is starting, you know, their learning path, then they don't have to make all the same mistakes and all of that. Okay, so I'm gonna make a ping. I think it also kind of goes to show, like you can see how few pieces kind of go into so many of these things, like making the cooldown on the attack. You know, it only takes a few lines of code, but if you don't quite know how to think about it, then it can, you know, which lines of code, right? So I'll make this ping, and I'm going to make a ping object that whenever we click, it's going to spawn that ping at a location, and the ping is going to fade away. And I think this is maybe an interface object. This world ping is going to have ping, and its lifetime, it's going to last for, I don't know, a second or something like that. When we draw it, we are going to have it sort of spring into existence and then fade away. And I give some examples of what I've used Perlin noise for, and when writing something to generate it, how do you know if you did it right? Yes. Let me wrap up this ping, and then I can end the stream with talking a little bit about how Perlin noise works and what it's for. I think that'd be kind of a good end point. All right, so the scale of this ping is going to be 0, and I'm going to develop this piecemeal so you guys can kind of see what this thing is doing. So first we're going to say scale equals lerp scale 1.3, so that's going to make it kind of grow into existence. Let's also give this thing a color, so that when we spawn it, we can change its color. Zero color alpha. Just do that. Okay, and I'm going to make a function called spawn world ping. Okay, and this is going to actually, we can probably just give it a location, and then we will allow for an optional argument. Okay, so we have this script that's going to allow us to easily spawn this ping. And we can give it a color if we want. Let's go back to our gameplay controller. And let's actually, no, let's go to the cursor object. Let's just say if we click anywhere, then we will spawn a ping there. So spawn world ping. Actually, I think we want to move this to the beginning step. How do you keep depths like this from getting out of hand? You mean, what do you mean, like in the ping? Like depth equals this? Is that what you're talking about, Shamus? Okay, so our cursor, mouse X, mouse Y. All right. So presumably when we click with our cursor, then it's going to spawn a ping where we say. Assuming I actually did that. I don't think I did. Yep. Cursor X world. Cursor Y world. Alright, so this is going to allow us to spawn the cursor where we click, but it's just going to stay there. Or spawn the ping, sorry. Did this backwards. How do you decide what gets priority? Oh, yeah, so usually I'll make a script that's called like init depths or something like that, and it'll set depths. I think we might actually have that somewhere. Yeah, so here we have this, which is, these are depth modifiers for things out in the world. So anytime we spawn terrain, we always spawn it 50,000 pixels back, or 50,000 depth units, whatever, back. Shadows are then 10,000 pixels, or 10,000 layers closer, etc., etc. So as long as you consolidate all of your depth management in one place, then you should be fine. Spawn world ping. All right, so we should be able now to see these pings kind of appearing. They have a nice smooth lerp to them, but they don't go away, right? So that's kind of the next step. And that's where this lifetime variable comes in. So lifetime starts at 1, and all we gotta do is just say lifetime minus equals second since update, and alpha equals lifetime times 2, and then they get destroyed. People power fan. So you make missions. I'm not quite sure what that means. Like missions for some specific game. If you're into that, you should check out Levelhead. You can make all the missions you want. Okay, so now as I'm clicking, these pings are nicely fading away, but it's still kind of weird that I can have a whole bunch of them on screen at a time, right? So it should be the case that whenever I click, then the previous ping goes away. So let's do that. And I'm gonna make a new script called destroy similar. I guess destroy same. So all this will do is it'll go through all the other versions of that same object and destroy them, unless it's the one that's calling this. So destroy same. So now when I click, then the previous one goes away. And even though it kind of just instantly disappears, it still feels pretty good because of the lerp that happens with the new one. So like in your mind, it kind of fills it in as if it's like emerging somewhere else. Dog's getting restless. All right, so I think that ping is pretty good. So next stream we can do stuff like if you click out here, then we can make some kind of a like an X ping or something, or make it come up red to say like, yeah, no, you can't really do anything up there. We could also do smaller ping, and we could even use this as a target selection reticle. So like if I clicked on this flower thing, then it would select it as a target, and we would kind of draw a little selection area around it. So that would be pretty nice. All right, I'm gonna push this. I'm gonna quickly let the dog out. We'll talk about Perlin noise, and then I think that's it for today. So. All right, we'll be right back. All right, never mind. She just needed to move. Okay. So, you want to know about Perlin noise? Zeok. Zeok, you still around? All right. So, Perlin noise conceptually is, let's see if I can switch gears here. Okay. You guys just see a big blank screen? Let's see if I can use my chalkboard here. I haven't used this tablet in quite some time, so bear with me while I make tremendous mistakes. All right. So what we're going to do here is talk about how Perlin noise would work in like a world generation concept. So let's say you got this grid. And you want to spawn terrain in the world, right? So thinking like Crashlands, you've got, you know, some of these might be mud, some of these might be water, some of these might be grass, whatever. Okay. So the basic idea behind Perlin noise is you want to come up with some kind of a way to generate random numbers so that you always get the same random number, but whenever you give it the same inputs. So if you think about a coordinate plane, so this is going to be 0, 0, going to be 1, 0, 2, 0, etc., right? So the idea should be if I give this thing a 2 for the x and a 0 for the y, then those two numbers come together to get some new single input, which is the seed. Okay, so that means, and then if I give it 1, 0, I get a different seed. If I get 0, 0, another different seed. So, yeah, I did talk about this in a previous stream. I think that VOD is dead, so it's probably good to just talk about it again. Okay, so So anytime you combine this 2, 0, you get the same number. And when you use your random number generator, then you just say, random set seed and use that number. So that would be maybe like you're trying to decide if there's going to be a rock there. You roll your random number, and then that will, based on that seed, always give you that rock. Okay. So that's just the basics, and so you'll know if Perlin noise is working correctly if every time you come back to the same place, then you get the same result. So every time you give it 2, 0, you always get that same outcome. So things get a little bit more interesting when it comes to world generation, because you don't want just complete randomness, right? Like you don't want like in every single grid space, water, then mud, then grass, then water, then grass, then rocks, then grass. It should feel more like there's kind of a continuous flow. So you would see like an area of rocks and an area of water, area of grass. And those things would kind of bump up into each other in an understandable way. So the way you're going to do that is through interpolation. So let's see, I think I can erase this thing. Okay. So what you're going to do instead is you're going to break this thing apart into chunks. Love this brush. Yeah, there we go. So instead of generating random numbers on every single space, you're going to say like, okay, I'm going to say every chunk is maybe like 3, right? Multiples of 3. So when you get to this first space, that's all fine. When you get to the second space, you're not going to generate a random number there. You're not going to generate one here, or here, or here, etc. Because we're going to interpolate those instead. Okay, so what this would mean is, let's say we want to figure out what's here in this space. What we do instead is we would grab all of the surrounding random numbers. So we would grab the 0, 0, we'd grab the 3, 0, and we would pull them all together in some kind of mathematical formula to figure that out. So you might do like an average or whatever. There's a lot of different functions, and when you see people talking about Perlin noise, usually they get mostly caught up in all the different interpolation functions. So I think in Crashlands we did some kind of a weighted average by distance. So we just said like, okay, if I want to know, what's in this space here, then I need to grab these 4 surrounding numbers, see what they get, and then see how close I am to all of them, right? So get my distance to all those points, and then I'll just take a weighted average of those things. So, okay, so that's how you would kind of like fill in the gaps, but then the final bit is like, what do you do with that information? So this is where you would use something, in Crashlands we would just call it a height map, which I don't know if there's like an official term for it, but if you think about it this way, so every grid space we can generate a number from, let's say, like 0 to 100. So when we hit our random numbers here, like the 0 or the 3 or whatever, when we hit those random numbers, they can give us anything from 0 to 100. And we then divide the world up. So we'll say, okay, anything less than 20, this is going to be good. Anything from 20 to 30, that's going to be water. And up to 50. Excuse my handwriting, it's kind of hard to write on this weird tablet. Etc. And then maybe up here, this is like grass, you know, from 50 to 70, and then like maybe from 70 to 100, this is like rocks. Okay, so when we roll our random numbers in these different areas of the world, then as things fill in those interior gaps, then you'll end up with a nice smooth flow of pieces of terrain that makes sense. So let's just say you generate. Actually, let me use the actual numbers here. So let's say you generate mud. Oh, no. All right. Let's say you generate a 0 in the top left corner, and then you go a few more grid spaces, and then you generate a 50. Then down in the bottom right, you generate 100. Bottom left, let's say you also generate like an 80 or something. Okay, so these are your grid spaces. The ones that you know. So if you want to figure out what's like in this space, here, then you would grab the 0, grab the 50, grab the 100 and the 80, and you would generate a weighted average based on distance. And so you would probably get some number, since you're super close to the 0, you would get some number that's a bit lower. So you might get like a 20 or something like that. It really totally depends on your formula that you use. And so you'd say like, okay, 0 is mud, right? So that's mud. 20 is like just about to water. So this is also going to be mud. But then as we go further out, then this next one is definitely going to be higher. So this probably becomes water, and this becomes water. Because these surrounding numbers are sort of pulling the average. So as you increase your chunk size, you will get larger and larger patches of terrain that are all the same, that are all contiguous with each other. And if you shrink your chunk size, the randomness goes up. And if you go all the way down to a chunk size of 1, which means you're just getting a totally random number in every single grid space, then now you're down to just pure randomness again. So it really just comes down to only generating specific random numbers in certain places and then filling in the gaps in between by taking all those known random numbers and using a formula to calculate the inside. So that's kind of the basic framework of Perlin noise. If you're interested in doing this, I'd recommend just playing around with it and trying some stuff. The first thing you need to do is just that pure randomness that's always the same in the same place when you come back to it. Once you get that figured out, then moving on to this part it's a little trickier, but it's not that big of a jump. So, okay, well, I think would you get a very similar effect if you just do a Gaussian convolution on pure random? Yeah, that's possible. The idea here is to explain Perlin noise in a way that somebody who doesn't know a lot about the math behind it would be able to employ. Is world generation done like this in other games as well, like Minecraft? Yeah, Minecraft probably uses some kind of, well, three-dimensional Perlin noise or something similar. There's a lot of different mechanisms of this, like there's fractal noise, and there's a lot of variations and iterations. I think it took me a long time to figure this out, primarily because of the fact that this kind of thing is usually explained by people with deep knowledge in mathematics. And they just don't know how to talk about this in a way that people without that knowledge can sort of like fill in the blanks. So it is kind of, it is definitely can be confusing, but once you kind of figure out this idea of you can always generate the same random number with the same random seed, take your grid spaces, turn them into seeds, and then you can start to play around with the world generation. So, all right, you guys. Well, that's all the time we have for this week. Thank you very much for coming to watch the stream. I'm not certain what will be happening next weekend, but I will be putting up an event on the stream. So if you want to come back and check this out, then feel free. As always, the source code for this is available in GitHub. And so there's links on the Twitch stream as well as on the YouTube videos. So thank you very much. Have a good weekend.